Right, hi everyone. Welcome back to Intro to Backend. Um, today we'll be talking about relational databases. I lied last time. This will be the last time you'll see SQL. We're still going to be using SQL this lecture and for the demo as well. But yeah, afterwards, no more SQL. Let's get into some announcements. So PA1, the first assignment is due tonight. There are slip days. However, like it's best to do it by tonight, and we'll be grading it over the course of this week. Yeah, the grades probably be out after spring break, right? Yeah,
Yeah,
because well, the
probably.
grades will probably be out after spring break. Um, what else do we need?
We'll try to get the grades in before PA2 is due.
Yeah, hopes but PA2 is due like Monday, but yeah,
That's starting spring break.
it's not during spring break.
Whatever.
But
Yeah,
yeah,
you're right.
just check the textbook for any of the dates. All right, so today let's just review what we've learned so far and get into the new stuff, which is the relational stuff. Um, so we have the client and server client sends a request to the server, and then we have the three operations like last time. The route gets triggered. You have the data operation. And last time we learned that we actually use SQL instead of Python dictionary. So what happened during the data operation is your server communicates to your database with a SQL command, and the database will give you back the data. For example, like select all from task, for example. Send it to the database, and the database will give you back the data that you queried. That's the data operation part. And then it will return a response. So after the data come back to the server will package it into a JSON object, right? And then it will send it back to the client as a response. Yeah, so that's basically what we've been learning so far. The whole diagram looks like this. So we add another thing, which is a database. That's why we're using SQL. It's just the language to connect server and database. Um, yeah. And yeah, just to go through again, instead of requests, SQL command, data, and then response. Yep. So, what we've been doing so far is we have a single table database. So the table structure information is into rows and columns. The columns are the fields, and the rows are the objects that have like features. Um, and then we use SQL to query and manipulate data to like communicate between the server and the actual database, right? So this is where we are in the course right now. Relational databases, the one in green. Um, yeah, after this, we'll be learning abstractions, which is we're using an ORM to like abstract away the SQL. So there will be no more SQL after this week. And then after that, we'll learn like the rest. So like containerization and DevOps, this is like deployment. Same with number 6. And then we have the hack challenge and images. Those are all coming up. Yeah. So any questions so far? Like on the course content, logistics, all good? All right. Um, let's go. So let's go into relational databases now. So just like the name suggests, relational databases, they allow relationships between data. So for example, like last time we had posts and comments, like you've seen in PA1. One post can have like many comments, right? And there is a sort of relationship between the two. And the way we've been dealing with it right now, in your guys' implementation, it might be sort of different. But we want a way to store the information that these two posts and comments are related. So like another example is like which users are friends, like on Instagram or something like that. And then like for example on Venmo, which is your upcoming assignment, which transactions like relate to the senders and receivers. So right now we don't have a way to store this information, like the relationships between data. Right now we're only storing single table data, right? So today we're going to teach you guys how to do that. And this thing is covering.
Just make it
Yeah.
a little smaller.
Oh, okay, nice. Yeah, so here's the example of like the user and post table. This is stores all the users, that one stores all the posts. And you can see in the post table, we store which user created the post. So here we have user ID 2 and 1. So in this case, Sky created this post, like either recorder code base, and then like this one was made by me. Um, but yeah, as you can see, this is how you connect these two tables. So we store a column of the user ID of the creator, and that way you can sort of encode the relationship that row corresponds to this row in the user table. So you can see a sort of relationship. One key topic to notice and to remember is foreign keys. So this stands for a column in one table that uniquely identifies a specific row. And it's also called a secondary key, but that user ID field in post table, the one just now, that is the foreign key. So it's the same thing as a relationship. Just to get back the diagram. So the most right column, this one, this is essentially storing your foreign key. So it's the column that dictates what it's related to. So in that case, it's storing the user that it's related to. Yep. And now we get into the different types of relationships. We have one-to-one, one-to-many, and many-to-many. We'll dive like deeper into each of these. But essentially, on a high level, one-to-one is a relationship where you have one object can have only one other thing connected to it. One-to-many, one object can have many things connected to it, and many-to-many is like multiple objects all can be connected to however many things they want. Yeah, let's go on to one-to-one. So this is how a one-to-one looks. Imagine the green things as like rows in a table. So row X in table A, so for example, the first row right here refers or is like related to one row Y in table B. So every row can only be connected to one other row. For example, students and net IDs. So each student can only have one unique net ID, and one unique net ID is unique to one student. So like you cannot have a student with two net IDs, or you can't have one net ID that's connected to two students, right? They have to only be connected to one object. That's one-to-one. And this is an example of one-to-one. You have the user table and you have the net ID table. And as you can see, ID in the user table is connected to the foreign key, the user ID column in the net ID table. And for row 2, for example, this one is connected to the net ID table with ID 30. So this is how you store one-to-one relationships. Just add an extra column, a foreign key column on one of the tables, and that way you can encode like the relationship between two tables. This is a bit more technical. This is the SQL query to make it. To go over it slowly, the first one, create table user. This creates the left-hand side table just now. It creates just a table user with ID and name. And then the second query here, create table net ID. It creates a table named net ID, has the columns ID, net ID, user ID, and that's the foreign key. So like user ID right here is the foreign key, and the way we connect it to the user table is we use the keyword foreign key user ID, which is the column in net ID, refers to user's ID. So essentially this column, we're connecting this column, user ID, to users, which is in this case, the table, users ID column. So that's how you connect it in SQL. And Scott will show you later. But yeah, that's how you connect it. Yep. And then when you're inserting, for example, you just insert into user a name with you insert into user an object with name like Josh, and then you insert into like net ID, like net ID JD2262, which is my net ID, and a user ID 1. This is how you just add a row into the table and it will connect it. You don't have to have any special syntax or anything. And yeah, that's one-to-one. Any questions? Yeah.
If you know that the relationship's going to be one-to-one, can you use the primary key also as the foreign key?
Use the primary key.
You are using the primary key of like
Yeah.
one table as the foreign key in the other one.
Yeah.
And the other one that
Like, could you give an example?
like if you use the ID in the post as
ID.
So like you're saying I just cover I covered this up, like I don't need this column.
Yeah,
Uh.
Yeah. All right, then where would
Yeah, I
I
see what you're
store
saying.
like the connection in that case?
Well, you would just have one-to-one and then two-to-two. Like,
Oh, I understand.
I think-
you mean like order it, right? Order it so it's like in one.
Yeah. I think in that case, you might as well just store it within the user table itself.
Yeah.
You know what I mean?
Yeah.
And a lot of times with one-to-one, like I find that it doesn't really come up that often because a lot of times you'll just want to be storing it within the user or like within the first table itself. So that's a good point that you
Yeah.
brought up.
But it's also like good practice to abstract things out. For example, like you have like imagine the users table has like 10 columns and you have the post table that has like another 10 columns. Having them all in one table is also kind of like messy, and it's also nice to abstract it out sometimes. Also it's good to like name them like user and post because they're two different objects as well, right? But yeah, in this case, it's not really a good example because user can have many posts, right? But like this is just one example of one-to-one. A better example of one-to-one was the net ID one, which is this one. But yeah, like you said, it could be like you could put net ID in the user table. That would make sense as well. Does that answer your question? Good. Any other questions? Nope. All right. So now we're going to one-to-many relationships. So this is where you can have one object that is referenced to by many objects. For example, a baseball team and players. So one baseball team can have many players, but a player only belongs to one baseball team. So in this case, if you see the diagram here, like the baseball team is the singular left-hand side block, and then these are the players. So like they're all connected to one baseball team. Yep. And here's an example of it. So here we have the album table, and here we have the song table. So one album can contain many songs, but a song only belongs to one album, at least in this case. So yeah, to read it, this is what you do. So you go to the ID in the album table, and you look up the rows in song table that have the same album ID, and that's how you see the connection. So in this case, you see like two are highlighted. So we got these two values. My bad. These two values are connected to the album voice notes, for example. And then for this one, we have these two rows connected to this album. So that's how you read or like reference this kind of one-to-many relationship. And this is just a syntax on how to create it. So first one here creates the table album. Second one creates the table song. And here it's the same syntax. You just use foreign key, and then you do album ID, which is the name of the column here in song, and then you reference it to the table album and the column ID. So this one, this column right here. Yep. And how to insert? It's the same way. You just insert it normally. So you also insert the album ID here to give it like the connection. And when you select everything, this should like show like which like songs have the album ID 10. Yep. Any questions for like one-to-many? Does it make sense? Yep. All right. So let's go to many-to-many. This one is a bit more complicated. So in this case, you can have many blocks, many like rows connected to many other rows. An example is student and courses. So a student can be in as many courses as they want, and a course can have a lot of students as well. So in this case, this is a many-to-many relationship. And the implementation, there are three potential choices. We're going to go through all three of them, but two of them are not ideal, just to show you why it does not work. So number one, we're going to try have multiple columns to store more foreign keys, and we'll show why that doesn't work. And then we're going to show you why a single column to store a list of IDs also does not work. And then we're going to show you why the number three is the best solution, using a join or association table. Yep. So here's the first one. Here's our first attempt of making a many-to-many relationship. So again, this is students and courses. They both can have like many relationships, right? So in this case, it's me and Sky, and these are the courses we take. But what happens if what happens if a student wants to have more than 3 courses, right? So what happens was you're gonna add a new student, but then they have like course 4 and course 5. So you can see the problem here. Like in this case, if you want to have more than 4 courses, more than 5 courses, you would have to add more columns. So you would have to add course 4 and course 5, and then set the rest to null. And this is a really, like, as you can see, this doesn't look too efficient. You're just adding column after column, and this is just not the ideal way to do it. And yeah, if you want to add someone with only one course, you would have like one course and then null and everything. So you're wasting a lot of space as well because all that space is allocated. Yeah. So one other way to do it is to have this method where you have a students table and a course table, and each one of these will show what course I'm taking. So for example, I'm taking the course 3700 and 4820, and it shows in the course table that my ID 1 appears in 3700 as 1 and 4820 as 1 as well. And yeah, this is how it looks. So like these two are referenced here. And yeah, these are the IDs also referenced here. But the reason why it's not good is because if you want to add a new student with, for example, the same courses as myself, you would also have to add 3 to every one of these rows. So it would require you to add this in the student table and also add the IDs in the course table. This sort of works, but it's also inefficient. You would have to add like IDs here and like update them whenever you add something new. So the solution to that is to have right here. The solution is to have a join or association table. So a join table is a singular table where you store relationships between the student and the course. So in this case, I just have a table with net IDs, and in the course table, I just have a table with the title of the course. And we have a third table that stores the relationship. So student ID 1 has a relationship with course ID 3700, for example. So this maps the relationship between my net ID and the actual title of the course. So for example, like student ID 1, which is me, I can see in the join table that I have 2 rows. That means I'm connected to 2 courses, and these courses correspond to these ones, right? And for example, for like the other way, from the other direction, we have 3700, and in the join table we have these 2 rows, and you can see the IDs 1 and 2, and you can see which students are in 3700. So you can see how using this join table, it sort of allows 2 ways to reference. So you can see what students are in 3700, or you can see which classes this student is in. And the cool thing is, if you want to add a student to a course, all you have to do is add 1 row in the join table. So I don't know if I have a slide for this. Yeah, like that. So if Sky, for example, wants to enroll in algorithms, which
Retake
is
algo.
or yeah, you already took it, but like if he wants to retake algo, all you have to do is add 1 row to the join table, and that's it. You don't have to update data in other tables. You just have to add 1 row, and that will like store the information of the relationship. So yeah, this is probably the most efficient way to do many-to-many relationships, which you guys will do in your assignment as well. Yep, and this is the syntax for it. This is just creating 2 tables, student and course, with ID, net ID, and here's ID and title. And to create the join table, this is what we do. So we create a new table named join, and we give it an ID, which is also a primary key. And then we have 2 columns, course ID and student ID. And then those 2 will reference the columns in their respective tables. So course ID will reference the column in course, no, the column ID inside table course. And student ID, this one, this will reference the ID column inside the students table. Does that make sense? I can pull up the diagram once again.
Yeah.
Right here. Yeah, so like the last query, we would create this table, and then we would connect this column to this column, and then we're gonna connect this column to this column. So that's what the SQL query was doing.
Yeah. This is probably like the most confusing or in-depth concept we've gone through so far. Are there any questions on this before we move on and do a quick demo? Yeah.
Can you explain how the foreign key works in this situation?
You want to do it? I mean, I can as well.
You can do it.
Yeah, so basically, like, are you asking what foreign key means, or like what?
What is it referencing here, and then why?
Yeah, so the student ID here would be a foreign key. And what that means is it's a primary key, but in a different table. So this joint association table, it's not written here, but will probably have its own ID here just to like access any one of these rows, and that would be a primary key. But the student ID is a primary key in the student table. So this is referencing this primary key, and then this course ID is a foreign key, which is referencing this primary key.
Yeah.
Does that make more sense?
It's also in the name, so it's like it's a foreign key. It's actually the key of a foreign object. So like if this is a foreign key column, it stores the key of something outside of this table. So in this case, it stores the key of the student, like the student IDs right here. Yeah. And also, yeah, if you look at the query, we actually have ID here. So the join table actually does have its own ID. So you can imagine there's like an ID here, 1, 2, 3, 4, just to like enumerate like which row it is. Yeah. Any other questions?
Another random thing is that you can have things other than foreign keys in a join table if you wanted to. Like you could put a timestamp or something else. It doesn't have to just be this. It just requires that you do have these two.
Yep. It also isn't really a special table in a sense because you're actually just creating a normal table, but you're making it as a join table. So the syntax is basically the same, just that they have two foreign keys like branching out. So like one references each table. So that's why we have two. Yeah.
I feel like we should do an egg question.
Egg question.
So we like asking when to give us a one-to-many relationship.
All right. So you want to just make up a
Yeah.
choose like Instagram or Facebook or YouTube or something.
All right. Can somebody tell me the relationship between posts and channels on YouTube for egg? And it might be a little confusing. So
Posts and channels. Yeah.
Would it be one to many? Because channels can have many posts, but all channels can only have one. All posts can have one channel.
that's what I was thinking.
All right.
You got it.
It is a bit lighter.
Nice.
What else?
That was clean.
One more? You got one more.
Sure.
Or you want to do it during the demo?
Let's flip it. Can somebody give me a many-to-many relationship? Something with a many-to-many relationship. In the back. Followers. Yeah, like you can follow multiple people, they can follow multiple people.
Yeah. That makes you want to even
Sure. Yeah, this is hard. Yo, Yankees hat, watch out.
I shouldn't gotten that on video, dude. That'd be so funny.
That was perfect. That was a dime if there was no reach.
All right, let's move on to the demo. You can probably set it. Yeah, you got it.
All right. So it's going to be the same like way we did last time. So it's just going to be in SQLite in the terminal. I'll try and zoom in a bunch. So to get into that, you do SQLite 3. And you'll never have like an assignment like this. It's just to show you like the raw SQL commands. So let's start off by making a user table, kind of like we did last time. But this time we're going to be relating users, and then we're going to make them a profile as well. So I'm just going to give it away. It's a one-to-one relationship because each user, you're only going to have one like profile. Hopefully that'll make more sense in a second if it doesn't. But so we'll create a user table here. This is the same thing that we did last time, but we're just going to have an ID, which is an integer. It's a primary key. And we want it to auto increment. And then let's give each people a name, which is going to be text and not null. Then we end it with a semicolon as always, and we can just check that it got created. Perfect. So we have a user table. Next, we're going to make a profile table, and that should be a one-to-one relationship. So let's try and remember how we did that. So we will be making a profile table. As always, this is going to have an ID. Same thing as above. And also, Josh is just going to be drawing the tables along just so you can try and follow the relationships a little better, because this is not great to look at. Okay, so we're gonna have an ID, right? Cool. Then let's give each person like a net ID. This is all kind of random, but yeah. And then the thing that's going to relate the profile to the user is going to be that foreign key that we've been talking about. So how do we do that? We're going to try and reference this primary key here, like the ID in user. So we're going to name that user ID. Doesn't really matter what we name it, but this is just easy to understand. And this is going to be an integer. And it's not going to be a primary key, but it's going to be unique. And that's just another keyword to make it unique, but not a primary key. But it's not how you make it a foreign key yet. The way you do that is on the next column. If you remember, you type foreign key, and then you enter in the column in this table that you want to be the foreign key. So in this case, it's user ID. And we're going to have that reference the ID within the table user. Cool. Awesome. So now we've created a profile table as well, which will have a one-to-one relationship. We can just check that. Cool. All right. So let's just add some data into these so we can see how that works. So I'm going to insert, I'll do it myself first. I'll insert into the user table my name, which is I do insert into user and then values sky. Oh,
Got the name as user and then name.
Oh, yeah.
Into user.
oh yeah. Insert into user the column. So we want the name column here and then the value sky. Cool. I'm also just going to copy the same thing but add Josh. Just press the up arrow key to get to the last one. Cool. So if we just did like select all from user, we can just see this is as normal as last time. Same story. Now let's try and insert into the profile table. So to do that, we'll insert into profile and then the columns. So we'll do a net ID because that was there. And then we're also going to need to put in the user ID. And then we'll put in the values. So I'll do Josh first. So his net ID is JD2262. Cool. And then his ID was 2. Cool. So I'll just do 2. And then we'll insert myself as well. DSS354 and 1. Cool. And then just to show you guys, if we tried to like insert in somebody who didn't exist, and then we tried to use the same key here, because it's a foreign key, it's going to require that this is unique. So it's going to fail on us because I already exist with 1. Even though this isn't a primary key, it's a foreign key and it's unique. So yeah, that will fail. All right. So that's all for here. I guess we could do just a quick select. And yeah, we can see that there is this primary key here. Then we have a net ID, and then this is the foreign key referencing the primary key in the user table. Cool. So that's a one-to-one. Let's try a one-to-many. So we mentioned like users and posts. We'll do a post here. So we'll create a new table, post. And as always, this is going to have an ID. Your primary key. Cool. We're also just going to have it have a description. And now we need that foreign key again. It's basically the same implementation, but we can make multiple of these. So we're going to have a user ID, which is going to be an integer, and it's not null. And then we're going to set that to be a foreign key for user ID. I mean, this user ID here will reference the ID column in user once again. Cool. So let's just check that got made. Perfect. Now let's try and insert into this. So insert into post. Cool. We want to pass in, we have a description and a user ID. So we'll pass those in. Okay. I'll make Josh's posts. He's studying for algo. And he has ID 2 here, I believe. Yes. Cool. So that should be good. I'll make a post for myself as well. My description is going to be smiling through it all. Can't believe this my life. If you know, you know. All right. Cool. Now, let's try and get like all of my posts. So the way we do that is select all from post where user ID equals 1. And this will get all the posts from the first user, which is me. And yeah, smiling through it all. Perfect. And yeah, so that's a one-to-many relationship. Again, not too bad. Let's try a many-to-many now. So in the same like social media sphere, maybe hashtags would be a good example. So one post can have many hashtags and each hashtag can be linked to multiple posts. So let's create a table hashtag with always going to have that ID, integer, primary key, auto. And then it'll just have a name or like a text for the hashtag. And we want that to be not null. Perfect. Was that created? It was. Great. So now we have to create that join table between the two before it can work properly. So the way we do that is create table, and you can name it anything you want. So you could just name it join. In this case, I'm going to name it feed, just arbitrary. And yeah, this is going to have an ID as always, integer, primary key, auto increment. Cool. And then it's going to have those two foreign keys again. So we're going to have a post ID, which is just an integer. And we need that to exist, so not null. And then we'll also have a hashtag ID here. Yeah, hashtag ID integer, not null. Perfect. Now we got to make these foreign keys. So we do this the same way. It's just foreign key, the name of the column. So we'll do post ID. And then references, the ID within post. Cool. And then we will do another foreign key of hashtag ID. Have that reference our hashtag ID. Cool. So this is just the same way. It's just a normal table, but we have these two separate foreign keys in it that will help us connect the two tables. I feel like I'm going pretty quick, just trying to get everything done, but we do have time. So do we have any questions about this before I move on? Tables. We have this. Yeah, we have our join table feed. We have hashtag, we have post. Any questions about this or about yet? Yeah, exactly. This foreign key makes it so that these cannot be duplicates because it would be a violation of the fact that post ID, which is just the same as the ID in post, is a primary key. So that can't be duplicates as well. Yeah, so a one-to-many is just like here. We'll just have a foreign key because I think you're confused about how would we have duplicates if it's one-to-many? Basically the foreign key here is user ID, Hold on, I need a second to think about it. Each post can have one user ID. Each user can have multiple posts. I see what you're saying. That's a good point. Wait, does the fact this is a foreign key make it unique necessarily?
Oh, you mean like you wanna
Like
this
in
is
one
for
to many, you
using-
have the like foreign keys being the same. So I guess it doesn't constrain.
You mean like in this, like if you look at the table, like, you
Mhm.
mean like have like one row, like this is like because this is only made by like one, like user one, for example, right?
Yeah.
That restricts that it's only made by user one.
Mhm.
So what was your point?
Like you can have multiple
User
foreign keys, and that's fine, right?
wait, multiple foreign keys?
No, like multiple rows
Multiple
with the
columns?
same foreign key.
Oh yeah, you can
Yeah.
have like, so like in this case, like I could have like a description like I here.
Right.
This could be made by user ID one, so that means user ID one and user, so Sky, he made this, so this is connected to Sky. And then here I could have another one, so I could have like, he says like, yo, for example, and this is also user ID one. That will also make sense because it's one to many, right? So Sky would also have made that because it's user ID one. In this case, it's also Sky. So he could have like one to many. So he could like one user can have many posts.
Yeah.
Does that
Yeah.
make it
No,
clear?
it is totally fine to have duplicate foreign keys. I was tripping. Yes, that's by design.
He-
Like if it's a one-to-one.
Mhm.
We prevent people putting.
Mm. Yeah, I think we just basically make it so that, so in this case, yeah, that's a great question. In the one-to-one, we had this unique keyword on the user ID. So that's how you would do, like make it one-to-one as opposed to many, one-to-many. So the only difference between a one-to-one and a one-to-many is that here the user ID will be unique. That makes sense, right? Yeah.
So by using the keyword unique, it makes sure so that one column, it cannot have, like in this case, this is the one that's unique, right? This table right here. So it cannot have two rows with like user ID one. That's what unique means. So it like, so that's the one that will enforce the condition that it's unique. That's why we use the flag like the keyword unique. Got it.
Cool. Any other questions? That was good. Okay, cool. We'll insert some hashtags now. So the way we would do that, inserting the hashtags is easy. All we're doing is just inserting into hashtag table, into the name column here, the value, whatever we want. So we'll do hashtag Cornell. And then I'll do hashtag LeBron. Cool. Yeah, this is just normal. Cool. We have two hashtags, Cornell and LeBron. Now we want to associate the hashtags with posts. So I want to put hashtags on my posts. So how would I do that? All we need to do is make one entry into our join table. So the way we do that is just insert into feed, which is our join table. Then we're going to pass in both a post ID and a hashtag ID. And we're going to do the values. So the first post was, did I ever select all from post? I think the first post was this one, like studying for algo. So I'll pass in that post ID and I'll give it the hashtag Cornell. Cool. The next thing we're going to do, I'll just make a couple more. So I'll make my post hashtag LeBron and my post also hashtag Cornell, just to show you can do that. You can have multiple hashtags here for the same post. And then if we do select all from feed, which is our join table, you can see that this has worked. However, this is very bad to look at. This is the primary key, this is the post ID, this is the hashtag ID. So it is working, it's just bad to look at. There is a way to make this better to look at. I'm gonna type it out, but it's not in the scope of this class. Yeah. But it involves doing some join, so it's an inner join in this case. But yeah, just gonna write it out so we can look at it. Basically just connecting multiple things in different tables is the way that SQL has for us to do this. Yeah, I'm just trying to like write it out. We're not going to ask you to do anything other than like the simple operations in SQL, but yeah, you should look into this if you're interested. Cool. And now we can see like the posts studying for algo with hashtag Cornell, smiling through it all, hashtag LeBron, smiling through it all, hashtag Cornell. Cool, just an easier way to look at it. Yeah, and then there's also a way to like include the user that's posting it with another command, but I'm not going to write it out because it's just kind of boring and not in the scope. Yeah, so that's everything for our demo today. Are there any questions before we move on to the Kahoot? Cool. Yeah, if it's confusing now, I think it'll sink in over time. It's a little bit confusing at first, but
Also take note, this is the type of drawings you kind of want to do when you're designing a database. It's like one thing we wanted to do this year that's different. It's like we want to teach you guys how to design a database. So later in the hackathon, you guys will have to do this probably. So like the front end people will say like, oh, I want to store posts, I want to store hashtags, I want to store users. And your job is to design the backend, right? So we're not going to give you the assignment like criteria, like the API spec. You're going to have to make it yourself. So this is something like you would do to like design it. So you would first of all like make your table. So you make a user table, you make a profile table, hashtag and post table, and then you would have to draw out the relationships between each of them. So like hashtag and post is going to be many to many. Therefore, I need another table like feed to act as a join table, for example. And then you have like user and post. Oh, they're gonna be one to many. Therefore, I need to add like a foreign key column in post so I can make it one to many. So when you're designing, this is basically what you guys will probably do. I recommend to do it on paper, but yeah, question?
Is there a reason for one-to-one, like relationships or like with your, just keeping it one table?
yeah, there are situations where it comes up, and a lot of times it's just a personal choice. Like if you think that two things should be designated as separate tables, if it would be cleaner to do that way. And there's also like I'll try and think of a good example of like when you would really want to use it. Because even like net ID, I would probably store in a user table. So I'll think of like a good example of when you'd really want to use it and bring it back.
Yeah, maybe a good example is like if you want to have an optional parameter and you don't want to have like null things in your table. For example, like here in the users table, if I want to have a column, let's say like I don't know, like has a white shirt or something, or like I mean that's true or false, but like an optional column, for example, that you don't want to have like a bunch of null like information. Oh, maybe like a column named like name of your dog or something, like dog's name. Like if I don't have a dog, if I don't want to store an empty string, I can make like a dog table and have like dogs there and make it one to one. So in that case, not everything has to have a dog, and I don't have to store like empty strings. But yeah, I think that's like one case you would use a one-to-one relationship, but they are kind of rare. So yeah, does that answer your question?